Let us continue our discussion on these illusions. We have talked about Muller-Lyer illusion, we have talked about Ponju illusion. There could be several other forms of illusions. Here of course, we are going to discuss only a couple of them. Let us now talk about the horizontal vertical illusion. This type of illusion will come into being say when you have something that is horizontally placed and something that is vertically placed, and although you see that that actual length of the horizontal and the vertical lines are actually the same, there is always a tendency that has been seen in human beings that make them overestimate the length of the vertical line. So, overestimation of the vertical line with respect to the horizontal line is another interesting form of illusion. Let us now look at this animation. You have a vertical line, another a vertical line which is of the same length, it has come out of it now, and then when you the moment you put it into the horizontal mode, you realize that the size of the horizontal and the vertical line actually does not seem to be the same, and that is an interesting construct in horizontal vertical illusion. The interesting part is that the overestimation will always take place with respect to the vertical line and not the horizontal line. We have seen it right now. So, in horizontal vertical illusion, the vertical line is perceived extending away from the viewer, and rather than rectangular shapes, the open vistas in the environment is pertinent for this type of illusion. So, once again we see that what we actually see in our actual environment influences how we would have different types of illusions. Let us talk about the trapezoidal window illusion. When you look at the window of a house from a certain angle, it looks like a trapezoid. Okay. You can refer to this image on the right. Okay. When you look at it in a very straightforward manner, you stand just in front of the window, you see a rectangle there, but from angle it seems like a trapezoid. Now, a rotating trapezoid window is perceived as oscillating window. The reality is that the window of any house cannot oscillate. This is the truth. But despite knowing this truth, what actually happens is that the moment you look at these trapezoid windows that exists in actual houses, and it is a trapezoid because you are looking at it from a certain angle. Okay. And if you look at the rotating trapezoid window, you start deriving a feel that it is not rotating, but rather it is oscillating. Right now you saw a house and then you had just a rectangular window there to give you a sense that from a particular orientation, when you look at the house, look at the walls of it, the window that it has which is actually rectangular, you perceive that it is trapezoid. Now, look at this very animation. Now, instead of a rotating window that you saw in the previous animation, see the animation here. Okay. It is of course a full window only that gets projected here, okay. And then you have a rotating window. The interesting part in trapezoidal window illusion is that the moment you start focusing on this rotating trapezoid, it actually starts giving a feel that it is oscillating. This is called trapezoidal window illusion. When you look at these illusions in a different culture, remember we have been talking about the impact of culture on perceptual processes. Now, if you look at the rural Zulu setting in Africa, in Natal, okay, their setting contains very few rectangular objects, and that is a very interesting thing, because the window that you saw, the house that you saw and the window there, or even the two animations that you saw right now, okay, it had a rectangular window, okay, and then that rectangular window you look at it from a certain angle and then you see it rotating. This is how you perceive it to be oscillating. What happens to those people where their environment does not have rectangular objects? So, this very study which was conducted on the rural Zulu population, it was found that their language also has the absence of words like a window, square or rectangle. Now, when they were compared with the urban Zulu children, a different result was observed. The rural Zulu children had less illusion compared to their urban counterpart, and this was the difference was approximately 60%. Now, the 60% reduction of trapezoidal window illusion that was found in rural Zulu children is actually attributed to the fact that rural Zulu setting does not have too many rectangular objects, and the language that the people from that very culture use, okay, it has the absence of words like window, like square or rectangle. Because you do not have it in your culture, therefore, you do not have the illusion also. So, most rural Zulu children did not report illusion at all, okay. And again those who had it, okay, there was no substantial reduction in their level of illusion by as much as 60% when they were compared to the urban kids who had an exposure to these structures, rectangular structures. Now, just try this exercise. Okay. What you see here on the white background, you have a couple of straight lines, okay, and all of them are of equal size. So, if you start putting balls here, okay, it has been put on all the lines now, and when you now look at these straight lines, remember the lines are the same. No, I have just put the balls here, and these black balls give you a feel as if these lines are actually not straight. Okay. So, here when you look at it, fine, you do not have the illusion. The moment you insert the ball, all these lines which are actually parallel to each other, okay, you start feeling as if it has been bent at some point, and at the other point it is not so. Look at this very image now. Okay. You have two vertical parallel lines here, but the moment you look at it, you feel as if it has been bent and stretched outwardly in the center. All these types of illusions we have, and the interesting thing here is that even though for things that we are very aware, say like the shape of the window, say the very fact that the railway tracks will always be parallel, the plates that are put between the two tracks for the trains, they are of the same size, still we have these illusions. Now, when you look at perceptual constancy and the impact of culture, a very interesting study I like to share with you, that West African adults, they demonstrate a greater shape and size constancy as compared to British adults. Now, African culture provide few opportunities to learn geometric forms, and especially the Bantu language, it lacks words allowing clear shape distinction. Say like when you look at the modern English vocabulary, okay, we know the distinction between the square and the rectangle. You also know that circle is not a sphere, okay, and a rectangle is not say a hexagon, hexagon is not a rhombus. So, for each of the variation that is possible in the geometric shape, we have a different language representation of it. Now, in African culture it has been observed, especially we are talking with respect to the Bantu language, okay, that it does not have very clearly demarcating words that makes distinction between different geometric forms. Now, when you look at the culture, when you find that you do not have actually the words that can match with those types of geometric shapes, you also do not have such types of illusions. Okay. So, somewhere the very fact that your perceptual constancy does not allow you to get have or do not allow you to have an illusion is actually a byproduct of the fact that there is a heavy influence of the culture in which you have been brought up, the type of words that are available, the type of forms that are available in the culture, and so forth. Let us talk about spatial orientation now. Spatial orientation such as left right, up down, they assume more significance in few cultures. Now, geographic features such as mountains and shores, they affect local reference system, and this in turn affects perception of our spatial orientation. When you look at the behavior of the sailors who go in the sea for and they have an opportunity to stay in the sea for long time, okay, very interestingly they do not have these reference systems available with them. No? So, they do not have the mountains available with them, they do not have the shores available to them, so that they can use them as their reference points. But very interestingly, if you look at their navigation strategies, very interesting patterns are found. Okay. Few sailors have the tendency that instead of looking at the plate which is just in front of them, okay, they will slant it a bit, okay, and if you cannot move the image, you bend your head like this, and the moment you make a change in your orientation of your head, the slant changes, okay, the image that you generate, okay, is different from what you generate in the normal situation, and this is how you have a better perception of the space. Sailors who have been too much into the sea, they even have got a very better impression of the habits of the local seabirds. So, how these birds behave, where they are actually found, what type of movement do they make, and accordingly they can very easily decipher know where they are actually in the sea, because they know that these type of birds are available only in this locality. So, the moment you look at the bird, you know where you are in the sea. They are even able to make a distinction in terms of the color of the sea water. Okay. So, you have a greenish tint, you have a bluish tint. So, depending on the color of the sea water, you can very easily understand where you are or how far you are from the shore. When you look at the changes in the wave formation, they can feel the boat in a wave of a particular course. They can very easily understand how far they are from the shore or where they are spatially located. Okay. And of course, star patterns is something that we all know, that you look at your position and then you look at certain stars, you know their position, and accordingly you understand which direction you are. Okay. And this entire construct of space with respect to where you are in the sea can very easily be generated. Now, let us come to motion perception. Perceived motion might occur in the absence of energy across sensory receptors, and the constancy effects that we have been talking about. Now, we have talked about shape constancy, we have talked about size constancy, we have talked about brightness constancy. So, constancy effect is even observed in the case of motion perception, and there are of course cases of apparent motions. So, little later we will be talking about three forms of apparent motion: stroboscopic effect, autokinetic effect, and of course, the induced motion. When eye moves with respect to spatial setup, objects in the space seem to move at different rates. If you remember, just some time back we had seen those videos that were shot from a running car. When you saw that the tree that was near to you, the rate at which it moved was different from the tree that was much distant from you, the rate at which that tree seemed to move. Okay. So, now depending on the eye movement in the spatial setup, objects in the space will always move in at different rates, and this rate depends of course on the relative distance. Now, objects closer to us seem to move faster compared to those which are far away, and of course, the greater the distance of the object, the smaller is the rate of movement. What actually happens is the lens of our eyes accommodate by changing its curvature to focus on the object. We have seen that fine when you remember that eyeball, and then you had a blue bar which was far off and a blue bar that was much closer to you. When you have the object of a particular size at a far distance, the size of the image that is generated on the retina is smaller, but the moment it comes close to you, the size starts expanding. In order to accommodate the lens of our eyes actually accommodate by changing its curvature, so that it can focus on the object. The lens becomes more curved when the object is nearer, and of course, it becomes relatively flat when the object is too far, and this is how our eyes accommodate depending on the distance of the object. Now, I am going to share a very interesting study with you. Lucia et al. Conducted a very interesting study. Now, it has to do with motion perception, but then this motion perception had this brain imaging technique, the functional magnetic resonance imaging technique used here. And what they did was that the biological motion perception was seen with respect to the activation of the brain. Initially, point lights were attached to major joints and head of a human walker. Okay. Right now, I will show you this image, and then the brain activation was measured using the functional magnetic resonance imaging technique. Now, here you see you have a human walker, okay, and this human walker now gradually you see if you move from the left to the right end of this spectrum, you have actually what was referred here to as point lights. Okay. So, all the major joints and the head, they are actually put in the form of point lights here. So, when you look at the movement pattern of the point lights, how does your brain respond? Okay. And this was the outcome of the functional magnetic resonance imaging. What is interesting was that the activation of lateral cerebellum and lateral occipital cortex was seen here. And remember that it is also you can see that there is a sensitivity to kinetic contours. Contours something that we had discussed some time back when we were talking to figure ground relationship. Just to help you recollect it, we had seen this image, okay. And the beauty here is that the figure and the backgrounds are not very clear, okay. And because there is an ambiguity, this optical illusion gets generated, okay. And you always will have to extract the image of the dog against the background, okay. And wherever we fail to do so, there are always cases where we construct our subjective contours, okay, because we want to have a full perception. You remember we had seen this, the still image of it, the animated version of it, that you do not see it as 3 different circles with piece cut out of it, rather you see as if a white triangle has been superimposed over 3 black circles. So, this part of the brain, it was observed in the fMRI that it was sensitive to the kinetic contour. So, what actually helps the brain figure out that there is a difference between what is static and what is moving. So, kinetic contour sensitivity was observed, okay, and of course, as we have discussed right now that the activation was seen in the lateral cerebellum and the lateral occipital cortex. Interestingly, the activation of the dorsal and ventral extrastriate cortical regions were also seen besides some other areas. This is of course not the full work of Lucia et al. No, it is just a selected part that I am sharing with you. Now, illusion of movement can also be created. Right now you saw different forms of visual illusion, right from Muller-Lyer to Ponzo to horizontal, vertical, trapezoidal window. We saw different types of illusion. Now, there could be an illusion of movement. You remember we had talked about that brightness constancy effect and how just you compromise with the brightness effect and then the full thing changes. Okay. So, you just see 2 spheres and then suddenly those 2 spheres gets converted as if these are 2 balls, spherical balls, and then the same image just depending on the change in the brightness level, you make them concave in one case and convex in the other case. This is what we saw some time back. Now, there is also a possibility of creating an illusion of movement. Now, look at this animation now. Okay, you see a blue ball and a yellow ball falling on the surface, and now if you look at it, basically it is this the shadow that is casted gives you an impression that there is a movement here. You look at this image, and the moment you focus in the center of this very image, you start feeling as if there is a movement. Okay. So, there actually is not any movement, but then the more you concentrate on the center of this image, the more you feel as if it is moving. Look at this image, all these figures are static, but then the moment you look at it, you feel as if all of them are moving. Okay. If you focus at any one, okay, just concentrate on any one of them and you realize that that becomes static and all others seem moving. Okay. These are illusions of movement. Okay. And say for example, if I am right now focusing on say the second row left figure, okay, that seems to me as static, whereas all others including the one just next to it also seems moving. When I focus now on the second one in the same row, that was looking to me as moving. When I look at it, when I stare at it, focus at it, it looks static, but then the other ones start moving. Okay. So, this is another form of illusion of motion. There could also be cases of motion perception where you actually have what we had discussed here as apparent motions. Okay. So, what you actually see does not exist, okay, in the cases of apparent motions. So, let us talk about the first apparent motion, that is stroboscopic effect. You must have seen moving objects when it gives a sense as if it is static. Okay. You must have looked at static objects which you know are static, but the impression it generates is as if it is moving. Look at the fan of this glider. When you look at this fan, you know that the fan is rotating, but this movement is not perceived. You feel as if it is static. You can try it in your own bicycle, for example. You run the bicycle, you pedal it hard, okay, so that the wheel rotates very fast, and then you get a feel that the object in the bicycle seem to be static. Okay. This is what is called as stroboscopic effect, because you know that the object is running, but the impression that you derive is that it is static. Look at this video now. What you actually see is a decorative light. Now, these decorative lights are very common in our culture. We find it on all major occasions, whether it is marriage ceremony or any other ceremony. You know that all these lights are static. You are actually looking at a battery of lights, and when the first light glows, the second light isn't, and they actually glow and keep blinking in series, and this series glowing and blinking of these lights give you a feel as if this is a running light. So, you feel as if one light started on the top and then it ran to the bottom, or it started on the left and went to the right, okay, and so forth. So, actually you know that the object is static, but the impression that you generate is of a running light. Okay. In the previous case, the object was running, but the impression that you derived was that it is a static image, and this is called stroboscopic effect. We come to another induced motion concept, that is autokinetic effect. Now, this effect can be very easily generated if you fixate at a spot of light in a dark room. That spot appears to move. You have a dark background now, you have a spot of light here. Now, it is actually static, but if I ask you to focus on it, it is a dark room, just focus on it, okay, you start getting a feel as if this white dot is gradually moving. This is called autokinetic effect. It is of course an animation to help you understand. Of course, the light will not appear to move so fast, and of course, it will not have so many trails left behind, but then this is actually what happens. You focus on it and then you feel as if it is moving gradually. Okay. Of course, not at the rate at which you see here on the screen right now, but you can try it out in your own house. And we now come to the third concept in motion perception, that is apparent motion, the concept of induced motion. In case of induced motion, static objects are perceived moving when the frame or the background moves. So, actually what is very interesting here in case of induced motion, that either you have, say for example, if I am the object and you put a frame around me, you move the frame, I am not moving, I am static, but because the frame moves, you feel as if I am making a move. Okay. Similarly, if the background moves, okay, my background moves, you feel as if I am moving. This is called induced motion. Now, look at this animation now. You know that this man is not cycling here, he has just his foot on the pedal, okay, the background is moving. But when you see that the background is moving, the impression that you get is that fine, this man is cycling fast. Okay. This is actually induced motion. The object that you are looking at is static, you are moving the background, but the impression that it is that the object is actually moving, because you are not interested in the background, you are interested in the object, okay, and you get the induced motion effect. The whole concept of static versus dynamic becomes very interesting when you look at your immediate world around you, okay, and especially when you have to represent an action, okay. Say for example, recently we had organized our Commonwealth Games, okay. Now if you have to make an icon for a particular event, okay, how do you design it, okay? Is there a possibility that the static icon that you design is designed in such a way that it gives an impression as if it is a dynamic image? So when you have any event for which you have to design something, you take an action. The previous example that I was taking, that you have the image, okay, and then you fit a frame here. All you do is that you have just broken the frame here, okay. Now if you look at this image now, this man, okay, his feet actually breaks the frame, and this broken frame gives you a feel. Although the image is static, it gives you a feel that there is some dynamism in this static image, okay. Look at this football player, he is an action, and when you put a frame and his two end of the two palms, they break the frame, it gives you a sense of dynamism. This image is not what you are actually habitual of looking at static images. So even though the image is static, the impression you get is that there is a dynamism here. I was referring to the Commonwealth events that India had organized very recently. Now for different sports events, say for example for cycling you have this icon, okay. You just what you do here is that you just change the orientation, and then the image that you see, the icon of cycling that you see on the right is more a dynamic representation of cycling compared to when you look at the icon on the left. Similarly, for a track and field event, you have say static version of it, although the second image is also static, but the moment you tilt it, okay, the action gets represented, and this is an interesting concept you realize actually in the practical usage of motion perception and how it helps in designing. After having discussed the details of perceptual processes, we now come to the individual differences that we actually visualize, that we sense. The truth is that all of us are equally expert in certain perceptual tasks. Say for example, speech perception. When I am talking to you, all of you can listen to me and you can perceive what is being told. Face identification, for example. You have been looking at my face through a series of lectures, and you can very easily identify who I am. Okay. We look at all those who are known to us, those who are very proximate to us in our environment. We know them, we very easily identify them using their faces. When you have when you think of object identification, when you think of scene identification, you identify the object that is shown to you. Say for example, when you are shown a chair, a table, a pencil, a pen, okay, a cupboard, a cup, a bottle. These are the things which the perception of which is very effortless for everybody. The primary thing being that fine object identification is very simple to us. You look at a scenario, okay, and when you look at it, you can very easily identify what it actually is, where this image was shot, the place, the location. We all are equally good at it. So where does the difference lie? The difference lies in perceptual learning, and primarily perceptual learning refers to the fact that one could have repeated exposure to a specific stimuli. Now, if you are exposed to repeated type of specific stimulation, then this repetition of stimuli that you are exposed to actually leads to perceptual learning, and it might occur, remember that it might occur without selective attention. It can induce structural or functional changes in the primary sensory cortex. This is what neuropsychological researchers have come forward with, and it leads to a remarkable improvement in our response to the environment. The best example could be say like wine tasting, for example. All these manufacturers, those who are involved in the production of wine, they have some expert who are very good at tasting the wines. No? So, you just take one sip of it and you can find out what is better. Similarly, tea tasting, for example, I had an opportunity to meet somebody who was in the tea industry in one of the tea gardens here in North Bengal, and I remember that man is his primary professional responsibility is to taste the tea, okay, every time when the leaf is supposed to go to the market. Okay, and the primary task that you perform is nothing except that you are very, very sensitive to the different elements that are ingrained in the taste sensation. Music perception, for example. Okay. Now, in music preference, you are trained in a particular type of a music, okay, and you, because of this repeated exposure, okay, you have learned something that has actually made some change in your primary sensory cortex. Okay. You can take the example of a specialized military training. In several professions, it has been realized that people are given very, very specialized type of an exposure to very, very specific stimuli. You must have seen police personnel when they visit the site of the crime, something that they can actually see is not very clearly visible to us. Okay. There are specialized military training, okay, where your capability to detect a particular stimuli increases manifold, something that all others will primarily ignore, even somebody in your own profession who is not trained into it. Okay. Of course, we have discussed the case of tea tasting, wine tasting. There are several such things where you realize that there is a repeated exposure of a specific stimulus, okay, and because one has been overexposed to a specific stimulus, therefore, the capability of the individual to perceive it with in the background of all other types of noise, okay, that increases manifold. So, that when you compare this information with the signal detection theory, your capacity to discriminate the signal against all types of backgrounds increases manifold, okay, and this is where individual difference starts coming in. Look at this session now. Now, this is a case of specialized training that has been given to few people in the armed forces, where one is supposed to detect the signal. So, when you have the radar facility, when you are made to sit on sonar, you actually get a very, very small signal. No? Listen to this beep. Now, this is the beep that you have to identify, okay, amidst all type of noise that you hear. Okay. Look at this visual signal. This is what you have to identify. Remember, this is not identified in isolation, but you have to identify it amidst that background where this signal appears. Okay. And such type of specialized exposure to this type of stimulus helps somebody detect it much easily. So, if I sit on a sonar, if I sit on a radar, if I am given a wine to taste, if I am given a tea to taste, okay, or if say you slightly tighten the string of a musical instrument, okay, I will not be able to make out the difference. Somebody who is trained into it, for him or her it is very easy, or I should say relatively easy. So, the readiness of an individual for certain kind of stimuli increases once you are exposed to it, and in such condition one does not consider all possible contingencies. Okay, that is the beauty of this training, and instead only a narrow range of possibilities are considered. Okay, so, when I sit on a radar as a novice, I will mostly commit errors because I see maximum degree of possibilities. whereas somebody who is trained into it will always narrow down the search process, no, and this narrowing down somewhere helps somebody very easily detect the signal. And this is something at times you realize that there is no specialized training needed for it, and it is basically an evolutionary what you call credit that goes to the mothers. Mothers are very sensitive to the cry of their babies. Okay. No women at before becoming the mother, beforehand nobody gets the training of motherhood. Okay. But the moment you become a mother, your sensitivity to the cry of your child increases manifold. Okay. And with the slightest of the signal of your child's cry, the mother will run to the child, okay, because she will get a feel that the child is crying. Okay. And this type of difference is seen between the mother and a non-mother. So, even within women you find a difference between the mothers and the non-mothers, and of course, with the same parents, the father and the mother, the sensitivity of the mother increases manifold with respect to the cry of the baby, and such type of sensitivity is largely not seen in males, the fathers. We are talking of set now. So, for example, we had seen this figure when we were looking at reversible figure. No? So, when you have ambiguity in the figure, what do you select as the figure and what is the background? Okay. Now, look at this image. You can see two things here. No? What do you see now? You actually see an old lady, okay, who has put a coat. Okay. Initially, you saw this, the image that was shown to you was this, but you perceive old lady. Okay, look at this zone, and somebody else will perceive it to be a young girl. Okay, and that is the time you actually look at the little protruding nose hair and the eyelashes. Okay, and you see as if you see at a young girl. Okay, and only the side profile is visible. So, it is something like this. You see only the nose and you see only the eyelashes, the side profile that you see here. Okay. Somebody will just look at the old face, and the primary distinction lies in the perception of this very area. Now, what are you actually set to look at? So, if I am tuned to look at a young girl, okay, I will be looking at, I will very easily perceive the young girl here. If I am not tuned to it, I see a old lady here. Okay, and this zone is always important here. Let me share with you a very interesting study. Lahaye et al. Conducted a very interesting study on a very small number of subjects. Just 9 subjects were taken into account. These 9 subjects, they had no music background. Okay. Now, without musical training, these 9 subjects were taught how to play 5 notes on a keyboard. Okay. Now, all of them were novices, they were not trained in music, and now 5 notes are taught to them, and once again they were given 3 conditions. 1, you listen to the song that you have just learned. 2, different song using the same 5 notes was played, and the third condition, when a third song with additional notes was played, and once again the functional magnetic resonance imaging technique was used. Their brain was studied. What happened in the brain? Now, the trained music brain, the findings suggested a bilateral activation in the frontoparietal motor related network. Okay. This included the Broca's area, the premotor region, the intraparietal sulcus and the inferior parietal region. Now, we said that we are looking at 3 different conditions. In the first condition, you see bilateral activation of the frontoparietal and the motor related network. Now, in the second case, you have the untrained subjects and the musics were of different notes. Here activation in the network was seen, but it was to a lesser degree, and you can see the difference. The trained condition and the same 5 notes are being played. You look at the brain records, you look at the same brain records where music of different notes are played, and you see activation, but then it is of a lesser magnitude. And now, when in the third condition, you have the untrained music with different notes, here you find equally familiar, but motorically unknown music did not activate the network. Okay. So, if you look at only the images, the first condition, second condition, In the first condition, the bilateral activation is seen here. Second condition, activation is seen here. No, you see the difference. The activation is seen here, but then it is of a lesser degree. But when you look at the third condition, the brain regions are not the same. Okay. So, this was the difference that was observed to give a feel, okay, that when you are set to perceive something, when you have undergone perceptual learning, what you perceive gets modified in this way. Okay. The modification that has been observed in terms of behavioral output, and these modifications have also affected the individual in terms of the brain recording, because the activation level differs. So, this was all about our understanding of the perceptual processes. At length we have started right from how the sense modalities operate, the visual system, the auditory system, the olfactory system, the sensation based systems, and then gradually how from sensation information is assigned a meaning, it becomes meaningful, we say that perception has taken place. And even when you are trying to you are attempting to provide a meaning to what you have sensed, there could be a condition where you commit an error, what leads to illusion. We have discussed all those illusions at length, but the most remarkable thing here are two. One, as an individual you are extra exposed to certain situation, or you are in a particular mindset, okay, and therefore your sensitivity to perceive a stimulus in a particular way increases manifold, and it is much more different from the remaining people around you. That is one. And two, because you do not have something available in your culture, or you do not have words representing certain things in your culture, or you have those things abundantly available in your culture, that also influences the perceptual processes. So, it is not actually what you sense actually is also perceived, you commit errors there, but these two remarkable things your individual differences and of course, the contribution of the culture, both are very, very remarkable in this process. This is now time for us to recapitulate what we have discussed with respect to the perceptual processes.